Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to be looking at protocol suites. We'll be discussing network protocol suites, the evolution of those protocol suites. We'll look at the TCP/IP protocol. We'll look at the TCP/IP protocol suite that goes with it. We'll look at the application layer, the transport layer, the internet layer, the network access layer, and then finally we'll take a look at the TCP/IP communication process. This episode is part of my series on Introduction to Networks. I'm Kevin here at KevTechify. Let's get this adventure started. What a protocol suite is a group of protocols that work better together. Some protocols work better with other protocols, and a lot of times we group them up into a suite. It's interrelated protocols necessary to performing a communication function. And so we have a couple of these network protocols out here, but normally these suites are organized into layers. Some of them have a couple layers, one has 4 layers I know of, another one has 7 layers. But usually the upper layers, they deal with the software, with interfacing with the end user. The bottom layers typically are concerned about the data and moving that data across their networks. And so a protocol suite is a group of protocols that work together. Now, the evolution of protocols. We've had several protocol suites as we've developed networks and gone through. There's typically 4 out there that we talk about: the TCP/IP suite, the ISO suite, the AppleTalk suite, and the Novell network suite. Now, let's talk about AppleTalk and Novell. Those were good when they were out. And when they were out was 30 years ago, give or take, somewhere 20, 30 years ago. Those were good protocols at the time. But as networks and the needs and the traffic and the data that travels across those networks, as that has evolved and changed over time, different needs have came. And so that's where we built different protocols to come in and replace that. So AppleTalk and Novell typically aren't used anymore because there's better products out there. TCP is the better product. The ISO protocol suite, that was developed by the Open Systems Interconnect, the International Organization for Standardization. And so they came up with their own protocol suite. It never really took off. It's out there, but the one you're going to deal with is the TCP/IP suite. That's what we're going to be looking at here, is how we set that up. The internet uses TCP/IP. Most companies, most networks, I would say, I will guarantee you 99% of the networks you run into over the course of your networking career is going to be TCP/IP. So that's where we spend all of our time on TCP/IP. We briefly mention it here, but we don't jump into the other networking protocol suites. TCP/IP, that is the one we're going to look at too. Here we have the TCP/IP protocol suite. It's an example of what we're doing. Data travels up and down. So if you see on the left side here, data is traveling up and down here. It's going from the network layer on the bottom, the application layer, and then it goes back down. And so the end user works at the application layer. This is the software. This is your web browser. This is the Windows operating system. That's what we're doing. And we push to have something go across the network. Now the application layer then takes it into the transport layer, which controls some of the communication. Then we put it to the internet layer, where we encapsulate it a little bit more, add some header information on there. Basically, this is the envelope we're sticking it into. This is grandma's address down in Florida. And then we have the network access, is how do we actually put it on the medium, onto that piece of copper, onto that piece of fiber, onto that piece of wireless. We send it across there, grandma receives it, and then it starts at the bottom. Let's take it off the medium. Let's make sure it's our IP address. Let's get up here looking at our TCP, and then finally let's display the message to grandma. And that's what we're dealing. That's the example here. If you like this episode on protocol suites and you get value out of it, and depending upon the platform you're using, please click that like button, give a 5-star rating, leave a comment, subscribe to my channel. Doing this supports the channel, which in turn helps me bring you more great content. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. TCP protocol suite here. It is made up of a lot of protocols. Looking here. Once again, we have our 4 layers: application, transport, internet, and network access. But each one of these layers have different protocols in there. Look at the application layer alone. We have a we have a naming system group that has DNS, but then we have host configuration, DHCP4, DHCP version 6, Slack. How do we hand out IP addresses? And each one of those groupings have multiple protocols in there. Then we have the transport layer. Is it a connection orientated or a connection list? Do we always keep that connection open, or do we start it and stop it when we need it? Then we have the internet layer. How do we get that message to its final destination? And then of course we have the network access layer. How do we get that? How do we actually get that on the wire and across our network from router to its final destination? And that's what we're looking at here. These standards are all made individually, but they're also made to work with each other. And so that's what's nice about this, is they all work really nicely together. So if you understand one, you understand all these layers, somebody comes out with a new protocol, you'll know where it fits into that. Now, the communication process. What happens here is we have our data. I'll picture you're sending grandma or something like that. We put a header on there. So this user data here, we put a header on. We put the TCP on header on there. Where is it? How are we packaging it? How are we getting it into a form that we can send? Then what we look at is we put another header on there. Where are we sending it to? This is grandma's address. This is that web server where you're asking. This is that web server where you're sending your web request to, and getting from the start to the finish. That's what IP address is. Then once we know where we're going, then we're looking at the internet. How do we put it on the media, and how do we get it from device to device to device to its final destination? That's what it's doing. So we've put on 3 different headers here. Then once it goes down there, hits the medium, hits this wire down here. It hits that wire. We then go to the receiver is going to get that information in. It's going to get it. It gets the string of 1s and 0s. That's what the computer sees. But because of the protocol, it looks and it says, okay, the first part of this is an Ethernet header, making sure that it got to me. Then we have the next part. So maybe this part up to here, this is Ethernet header. Then the next part here, this is the IP header. This is the IP address, making sure it gets to its end destination at that point in time. Then we have some TCP information here. That could be here at this point. And then finally we have our data. And we take that information off, and then we get down to the raw data. That's what we can use. That way we can display that picture on the screen. Now, this down here isn't necessarily drawn to scale. We have the header. We have the Ethernet header, we have the IP header, we have the TCP IP header. If that was this long in 1s and 0s, the data would probably be out another 100 yards longer. The data is a lot longer than what we show in these diagrams. So this picture up here, this could be, this picture up here, looking at these 3 headers, let's say this is 1 foot long. Just for an example. Then this over here, our data, could be 100 yards long. So it could be a lot longer. It could be 100 feet. Typically, these pictures aren't drawing to scale. And I did forget to mention, Ethernet does put a trailer, does put a caboose on here. So we do have that happening too. IP TCP only puts headers on. Ethernet does put a trailer on. Make sure that that information does get there. It was my pleasure to provide you with this wonderful episode on protocol suites. If you like this episode and you got value out of it, and of course, depending upon what platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com, and you can get all of these episodes in video and podcast form. In the upper right is my playlist for my series on Introduction to Network. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode on my series on Introduction to Networks. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.